Hello guys and welcome back to Lead Logics. This is the determine if a cell is reachable at a given time or not. This is a lead code medium and the number for this is 2849. So in this question we are given with four integers sx, sy, fx and fy and a non-negative integer t. So sx and sy are the coordinate of the starting position and fx and fy are the coordinates of the finished position, and t is a non-negative integer t, and we have to tell if we can reach from the starting position to the ending position in less than or equal to t time or not. And if we can reach, we have to return true, otherwise we have to return false. There are also cases like if the minimum distance is 0, it is not possible to reach the target in 1 second or less, so in that case we need to return false. So for this question we would be using something known as Manhattan distance. As you can see in the image, there are basically three distance formulas which are used in mathematics. Mostly you have used Euclidean distance in geometry and calculations, like x1 minus x2 whole square plus y1 minus y2 whole square all under root. But in this question we will be using the Manhattan distance, which tells the mod of x1 minus x2 and y1 minus y2. So we'd be using this Manhattan distance because the question is something like that. Like you can see, we have a start distance, we have a finish. So we actually need to calculate the uh, mod of x1 minus x2 and y1 minus y2. And because in grids we are not moving uh, you can say diagonally. Or in grids usually we measure the distance like x plus y, not we calculate the Euclidean distance. So that's why we are using a Manhattan distance in this case. So let's start with the approach. Let me first give you a dry run of some sort of the algorithm how we do it. So first of all we have the start cell sx and sy and the target fx and fy, and we have to reach, if it is possible to reach fx and fy from the starting position in exactly t side. So these are the things given in the question, or the variables. Now we need to calculate the Manhattan distance between the start and the target cell, which is the distance in x direction and the y direction. So for you can see we have taken the x distance, y distance, fx. So x distance is basically sx minus fx, and the y distance is actually uh, fy minus sy, and we have taken mod of these. So this is my x distance and y distance. Now we'll take another variable known as the minimum distance. In this minimum distance, we'll store the absolute difference between the x distance and the y distance, and minimum of both these. It will represent the shortest path to reach the target cell. That's why we are calculating this minimum distance. Like there can be multiple paths to reach this. You can go up and down, because we can move to back to the cell where we came from. So there can be multiple solutions. So to calculate the minimum shortest path, we are keeping this minimum distance. It is this minimum distance is actually calculated from the minimum of the x distance or the y distance. Now we have the minimum distance. Now simply what we have to do, just check if t is greater than or equal to minimum distance, and you can return the answer. So let's start with the coding section, but before that please do like the video, subscribe to the channel and share it with your friends. Now let's come to the code section. So we have defined the x distance and the y distance, and we have actually done nothing but taken the absolute of start x minus finish x and the absolute of start y and the finish y. So this was my solution for today's question. So the time complexity and the space complexity or this question is actually O of 1, because we are not using any extra space, and the algorithm has constant time complexity as it performs as a simple mathematical operation. So we have done it this question in O of 1. So thank you for watching the video. Have a nice day. Uh, the audio was distorted in between. I didn't saw my mic turned off. So I'm sorry for that. Thank you for watching the video. Have a nice day.